Hey everyone, welcome back to another lesson and welcome back to the final practice of this section. So in this one, we're going to do a much more complicated one. And in this one, we're going to be using a few things. We're going to use while loops and we're going to use if and else statements and all that stuff. And we're going to be also finding a solution to a potential problem that you can actually encounter in this situation. All right, so let's actually talk about this particular problem. So if you actually go to Reborg's world, again, you have to be here. This is the one what we're using for the practice. You want to check out the maze problem. So if you click on it, it's going to take you to the maze problem, and it's going to look like this. So the idea with this is that this is a robot that is lost, and you need to write a code that is going to guide it to the end zone here, which is this like flag area. And if you actually look at the world info, it's going to give you some helpful information actually. So it's going to say write a program using if, elif, and else statements so Reborg can find the exit. The secret is to have Reborg follow along the right edge of the maze, turning right if it can, going straight ahead if it can turn right, or turning left as the last resort. So again, the idea here is that basically you want it to go all the way to the edge, turn right, and if it can't turn right, you want it to go straight, and if it can't go straight, you want it to go left. So very simple, again, like it's just like we can see it, we can see the maze, and it's easy for us to find the exit, but obviously it's not going to be that easy with a robot, right? So as always, I have my turn right function here. I'm just going to leave it here because it's something I want to use. And let's actually go ahead and write this. Now, one of the things I want you to do is I want you to try to figure this out. So you can pause the video right now and try to see if you can write this using while loops and see if you can get it done. All right. So hopefully you tried. If you didn't, that's fine. We can actually go ahead and write this, and you can actually see if you made mistakes, or if there is a different way to do this. All right. So what I'm going to do is I'm going to start with a while statement. All right. So I'm going to say while not at goal. So essentially the idea with this is to keep this loop ongoing as long as possible, because because I want this to work as long as we're not at the end of the maze, right? So it's very, very important. So I'm gonna say that's what we're gonna start with, and we're gonna say if right is clear. So again, if you look at this, look at what we have here. Right is clear. These are some of the elements that we can use, like the conditions essentially. Front is clear, wall in front, right is clear, all that. So again, it's just one of the things is that it's really up to you on which way you want to go or how you want to solve this, and that's like why I love this, because it has a lot to do with your own creativity and your own style. Something that I mentioned like a long time ago, I think in the first section of the course, where like everybody has a different style and everybody has a different way of thinking and problem solving, right? So like you have all these like conditions available, and you can choose one based on like however you think you should solve this problem. But again, also there's a hint here as well. So anyways, the way I'm going to solve this is that I'm going to say if the right is clear. Let me just pick it right. There you go. I'm just going to copy it correctly. So we're going to say if the right is clear. All right. What we're going to do is we're going to say turn right. So that is basically what I'm doing, right? We're essentially telling it to turn right if the right is clear, okay? And then we're going to also say move. Okay, so now the next is we're going to do an elif statement, okay? We're going to do an elif statement, and I'm going to say if the front is clear, all right? And I'm going to explain this to you exactly what is going on here. We're going to say move, and else, that would be the final thing here, right? We're going to say turn left. So essentially, we basically built what was explained in the world info, if you remember. So we basically said, let me just see if I can drag it. There you go. That's better. So we're basically saying that, follow the right edge of the maze. So that's what I'm doing. So at the first, I'm saying if the right is clear, turn right and move. So like I'm just sticking to the right side and moving there, right? So that's assuming the right is clear. So if you can, and then going straight ahead if it can turn right. So, and then I'm going to then the next one is telling that to just go straight ahead, right? So the next one is LF, front is clear. That if assuming your front is clear, you're gonna say just move, basically going straight ahead, right? And then if you can't do any of that, turn left as the last resort. So basically else is gonna be the turn left. So if I close this and if you actually put this right here, and if you run this, let's see what happens here. All right, so let's see if it's moving, and we got 308 moves, so it's not ideal, right? But again, it's just really all about where you start. So let's see. So again, it's going, it's trying to get to the right side, and yep, so I think it is optimal. I feel like there's something wrong with it, but I can't tell. Let's see. And it's just like kind of going on every possible direction, and then it's just trying to find the right optimal. Now obviously this is not the most effective way to solve this, but yeah, so that's just like the algorithm that we created here. Now, one of the conditions I'd like to talk about, I'm just going to talk while this thing actually is solving this. One of the things I'd like to talk about is the fact that there are situations in this problem there, and the reason why I like this maze problem is actually that there are situations in this where you end up in like in a situation where you're going to be stuck in an infinite loop. All right, so you're going to be stuck in an infinite loop, and how would you actually solve that problem is another thing I'd like to actually go over. All right, so let's wait for this thing to finish. Finally, it's at the end, and it pretty much went through every possible scenario, which is like hilarious right now. But anyways, so that's that. All right, cool. So we went through that, and that's done. All right, so let me see if I can find a situation where we actually end up with this infinite loop. So right now, this is a done, problem. So like we finished it, all good to go. But I want to see if I can get to that situation where like get to that infinite loop problem. Okay, so take a look at this particular situation. So we have our problem solved, and a robot is just gonna based on the world info, it's gonna go all the way, it's gonna find the right wall and just like try to stick by it as long as possible, and then it's gonna go straight ahead if it can't, and then turn left as the last resort. So all that. But there are some particular situations where you end up in a situation where you don't have any walls around you. And when you actually don't have any walls around you, none of these conditions actually apply, right? So think about it for a second. So the first thing we say is that right is clear, turn right, but right is clear. So like, again, that's just gonna do that. It's gonna do this thing and move. But then if the front is clear as well, this is gonna go as well, and then it's gonna turn left, and again this is gonna end up in an infinite loop. If I run this, you're gonna see exactly what happens. Take a look. So we got 1,000 steps here. That's usually the sign of an infinite loop, because what is happening is that it's just going around itself. See, it's just going in a square, and it's just going all over the place. See, and this is gonna go forever. It's not gonna do anything. So this is like a particular edge case. This basically means that, sometimes when you write a program, there are some particular cases under certain circumstances you end up in an infinite loop, even though your while loop should essentially most likely cover everything. But there are some cases that is not going to be the case. So this is where I want to get into a bit of a debugging and the problem solving. All right. So let's think about this. It's essentially what is happening here is that we don't have any walls around us, and because of that, we're just kind of going in a circle, or like a square if you think about it. So how do we solve that? In my opinion, like again, I've been thinking about this a little bit, and in my opinion, my thinking was that we can actually just move it, and like before, let's say we can have another while loop, and if there, like we can say if they're like the front of the robot is empty, we can just move it and turn left, so we can just get it out of that situation, right? So here's what I'm thinking. So we're gonna say before this like main while loop, we're gonna say while front is clear, basically exactly the way we did this, right? So I'm just gonna say while front is clear, we're gonna say move. Okay, and then I'm just gonna say turn left, and this is not gonna be under the while, by the way. This is just like a separate thing by itself. Turn left. All right. So again, my thinking is that in this situation, we're gonna run this while loop first, and if it is around, if the robot is placed in a spot where like there's no walls around it, and if it says that the front is clear, for example, it's gonna just move it. Just gonna go all the way down and turn left, and that way it's just gonna face the right way, and we're gonna be able to get out of this loop. Now let's test it out and let's see how it goes. There you go. So we got 245 moves. That means this is a solvable problem, and we got out of that loop, and just like that, we're just finding our way out of this maze. So this is, again, I just wanted to kind of make an example of this. This is one of those edge cases. It rarely happens, but when you work on like programs and you have a lot of like while loops and everything going on, there are situations where you do end up with infinite loops like this, and you just gotta think about how you can solve this like particular edge case. You gotta find the problem first, understand it, and then like obviously code it in a way that is gonna fix it, right? So I just wanted to kind of make an example of that, guys, so you guys can see it in action. Anyways, thank you so much for watching this video, guys. I hope this practice was helpful. This one is a little bit more complicated, and we're gonna get back to Rebo's world later on. Right now, I just want to continue with the sections. We're going to talk about more other stuff in the next sections as well. But we will get back to this because there are some advanced lessons that are going to be pretty useful, and that we're going to be able to use this website to practice. So definitely bookmark it and like play around with it. Let me know if you have any questions. If not, I'll see you in the next lesson and next section and next videos.